This method can help address the key questions in the manufacturing field, such as how to reduce machining time and cost for pilot production. The main advantage of this technique is that micro features can be achieved on surfaces of complex parts thanks to additive manufacturing. Demonstrating of the additive manufacturing part will be Dr. David Pedersen, who is a senior researcher, and Federico, who is a PhD student. Mischkot, who is a technician, will do the injection molding part.
First, use computer-aided design software to design the insert. Here are depictions of the movable side and the injection side of a mold to produce a ring with 4 tines. The tines are at an angle of 60 degrees. The manufacturing tolerance is 1/20th of a millimeter. Next, prepare the resin for photopolymerization. Mix its components thoroughly in a mixing device for 30 minutes. For fabrication, choose a photopolymerization machine. Inspect the build stage and make sure the machine is properly set up for the fabrication step. Import the design and run the build at the highest vertical machine resolution. After fabrication, take the printed inserts to clean them. Place them in isopropanol in an ultrasonic bath for 3 minutes, 3 times. After the solvent evaporates at room temperature, place the inserts in a room temperature desiccator. Recover the inserts and cure them twice with UV flashlights. When done, remove the inserts.